Hey everybody, this is just a quick tutorial or video guide for PS2 Learning Set 2. It's the second mini CER we did in class, and it's the one that was graded. What this is not going to be, it's not going to be one of those videos where you can pause it and just copy everything down and do well because you copied. You actually are going to have to listen and you're going to have to do some work in order to do well. So the first thing we want to talk about are claims. And remember, I've got some posters hanging in my room, and you should be using those posters during the making of your CERs or during the writing of your CERs. If you use those, you're going to do much better. So here's claim, and this is basically what I have on my poster. Claim is just the statement about the results of an investigation. So it's only meant to be one sentence in length, so it's not meant to be a large paragraph. And it answers what can you conclude. It should not start with yes or no, or typically it doesn't. And it should describe the relationship between a dependent and independent variable. And that kind of depends on what I'm actually asking you to do. So here's what you saw in your test. And it says, make a claim about the relationship between kinetic energy and mass. That is what you're trying to answer. What is the relationship between kinetic energy and mass? So your claim should probably start out something like this. The relationship between kinetic energy and mass is. Then you have to answer, what is it? Now, some people didn't even use kinetic energy in their claim, which is really hard to do and get credit for it because it says, what is the relationship between them? So, for example, you might say the relationship between kinetic energy and mass is that the more mass you have, the less Ke you have. Maybe you said the relationship between kinetic energy and mass is that the more mass you have, the more kinetic energy you have. Whichever it is. Now, you have to look at your data down here in order to figure that out. So if I start looking at things, looking at my data right here, and we see that here's the light can and here's the heavy can. So when I look at those, I see that the light can, 27 millimeters after, they're both 30 to begin with. They were both dropped. This is important here because some of you didn't realize this, but they were both dropped from the same height. One squished 3 millimeters, the other one squished 7. So you can see that there is definitely a relationship between energy, kinetic energy, and mass. You just have to tell me what is that relationship. And I'm not going to give you the answer here. You have to figure that out on your own. And we've gone over it in class because we did the lab. So again, your CER, your claim should start out with the relationship between kinetic energy and mass is, and then what is that relationship? Now, do you need to start out that way? No. You could say the blank mass and then talk about kinetic energy. I don't want to give you answers, but you could say, well, for example, you could say the less mass you have, the more Ke you have, or the more mass you have, the more Ke you have, or the relationship is that the more mass you have, the less Ke you have, whatever it is. So those aren't necessarily the correct answer, although the correct answer may be hidden there, but that's what I'm looking for with your claim. If you have your claim wrong, it's really hard to get everything else correct. So your evidence. The big thing here with evidence, a lot of you did a really good job, but I'm just blown away at this part right here. A lot of you do a really good job with qualitative data, but some of you struggle with quantitative data. When we did the practice, we talked about how you have to use the numbers. You have to use the numbers. And some of you had absolutely no numbers in there at all, or you didn't have the right numbers in there. So when we talk about the light and heavy can, if you're going to start making, talking about a relationship between those two, you're going to have to use the amount of squish because that's what we did this for. We dropped it from the same height. We have different masses, so you can include those as well, but you have to somehow include the amount of squish because that's what separates the heavy can, which is more mass, and the light can, which is less mass. So make sure you have numbers in your evidence. If you don't, you're not going to get a proficient. It's really hard to get a proficient. Now, if you include some of the wrong numbers, you might get a developing, but if you don't include any numbers, it's hard even to get a developing. You're probably going to be beginning. And then finally, For the reasoning should be a good size paragraph. So some of you actually got an unmet grade for this because you only had a sentence. And we talked about this in class, so I'm not sure why you did what you did. So remember, the reasoning, you must restate the claim. You have to have correct scientific principles. And this is one of those things. If you use the poster on my wall, it says you have to include scientific principles. And it's right here. So if you don't do that, it's automatically going to be a developing at the very best. So again, it perplexes me when you don't use the posters, when I encourage you to use the posters. All you have to do is look over, on the wall and see, oh, I have to have a scientific principle. And then pick it. Pick the one that's correct. Now, if you don't pick the correct one, you may still not be proficient. But if you don't have a scientific principle at all, it's automatic then. So you have to restate the claim. You have to have the correct scientific principle. Then you have to explain, why is this scientific principle important? So you can't just state it. This is why it's important. And so let's look at the scientific principles. When we look at this, and I look at this right here, kinetic energy and mass. When we look at this one talks about Ke. The second one talks about kinetic energy, and it talks about speed as long as the mass stays constant. So you have to have something that talks about kinetic energy and mass. So sorry if there's a little interruption there. I had someone come in and do some cleaning, so I had to quick pause the video. So when we look at Ke and mass, this one has Ke, that's fine. This one has Ke, that's fine. But it has talked about the relationship between kinetic energy and mass. This one talks about speed right here. So this is not the one. But when we talk about this right here, an object's kinetic energy increases as its mass increases as long as the speed stays the same. So it talks about Ke and it talks about mass. In fact, that would be a pretty good claim as well. We're not talking about elevated objects. You might say, well, it is elevated. But if we go back to the data and we look at it right here, notice it's 30 centimeters. So they were both dropped from 30 centimeters. So we're not talking about gravitational energy. They were both the same. They have GE, but that was a control. We didn't change that at all. And then the last one is not used as well because it talks about GE again. So make sure you restate your claim. Just copy and paste it. You have to have the correct scientific principle in there, and you have to explain why the scientific principle is relevant. And then just a concluding sentence. So when some of you write your whole reasoning and you have one sentence, it's probably going to be an unmet. If you write a really good one, maybe it would be a beginning, but there's no way you can write the whole reasoning in just one sentence. So I'm hoping this video helps. I'm hoping that you can retake your CER and do better. After all, the better you do, the less likely you are to have to do more and more CERs in the future. Make sure you ask questions if you have them. Bye.